are the solutions to number theory? So in question number 1, this is a very basic dividing exponent or monomial rule, which is to keep the base and subtract the exponent. Usually our bases are variables, but in some cases the bases are actual numbers. So we're going to just keep the base and subtract the exponent. So 5 minus 8 would be negative 3. And we always write our answer in the numerator. And then because the exponent is negative, we're going to have to drop it to the denominator. So it becomes 1 over 2 to the positive third. So when we drop it, the negative exponent becomes positive. And then we can simplify that to 1 over 8. Another way of doing this problem is to look at it as a reducing fraction and to say to yourself, there are 5 2's in the numerator and 8 2's in the denominator. So I can reduce by taking 5 away from the top and the bottom, and it's going to leave me with 3 in the bottom. And so you could also get to 1 over 2 to the third, and then ultimately 1 over 8 that way also. Number 2 has a lot going on in it. This is a power to power rule. So is this one. However, the power is a negative, which we're going to treat a little bit differently. So first we're going to do power to power. So 4 to the third power is 64. Then we keep the base and we multiply the exponents. Now for this quantity, because it's all being raised to a negative exponent, I'm going to move it all to the denominator exactly as it is, except for the exponent. I'm going to make that a positive 2. So once I take and drop this entire quantity down to the denominator, then the exponent becomes positive. So now I have 64 n to the 6th over 4 to the second power is 16 n to the second. And then I can reduce my 64 and my 16. Let me double check. I'm pretty sure I know what it is, but I do make mistakes, so I'm just double checking. 16 goes into 64 4 times. 16 goes into 16 once. And then I'm going to, again, reduce my variables. The rule is to keep the base, subtract the exponents. So 6 minus 2 is 4. And again, I always write my answer in the numerator. If it's negative, I drop it down. Or I could have said to myself, I can take 2 n's away, and that would leave me with 4 in the numerator. So my final answer is 4n to the 4th over 1, which is just 4n to the 4th. Number 3, solve for n. So 5 to the 2nd times 5 to the n power is equal to 5 to the 6th power. So this is a multiplying variable rule. In this case, our bases are numbers. So the rule is to keep the base and add the exponents. So I need to figure out what n should be so that when I add it to 2, I get 6. So 2 plus what would give me 6? N has to be 4. Circle all possible solutions to b squared equals 98. So if b squared equals 98, I'm going to undo b squared by taking the square root. So if I take the square root of b squared, I get b. And then the square root of 98 is about 9.89. That is an irrational number, so it does go on forever without terminating or repeating. Now remember that all square roots have a positive and a negative answer. So technically b could also be negative 9.89 and so forth. If you don't remember how to put this in your calculator, you press second function and then your x squared button. Above the x squared is the square root, and then you would press 98 and enter. So now I have to determine which of these 4 choices is going to be equivalent or equal to that. So I'm going to enter 2 times the square root of 7. So on your calculator, that would be 2 second function, the x squared button with the square root above it, and then 7. So when I put that all into my calculator, I do end up getting something about 5.29. Again, that's irrational. So it doesn't end or repeat, and that is definitely not equivalent. So that would make this one also not equivalent because it's just the opposite, which would be negative 5.29. So let's check this one. So if I take 7 times the square root of 2, that is also going to give me the 9.89 that I'm looking for. So that's one solution. And then the opposite would be the other. Number 5, when you're trying to find the value of y, and y is raised to the third power, to undo that, we need to do the cubed root. So instead of taking the square root, I'm taking the cubed root, because the cubed root will undo y to the third. So when I enter that into my calculator, I get about 9.837. That is an irrational number, so it does go on forever and ever without repeating or terminating. And there is no negative to that. So only square roots have a positive and negative answer. This is just going to be 9.837. It says round to the nearest tenth. The tenth is the first decimal place. So I'm going to look at the second decimal place. So the answer is 9.8. because the 3 told the 8 to stay the same. Number 6, estimate to the nearest tenth. So when entering this into your calculator, second function x squared, because it has the square root above it, then 55. And you want to make sure you close the parenthesis, because this will automatically put a parenthesis in front of it. Make sure you close the parenthesis before adding your 10 to it. And then the answer is going to be 17.416. It's irrational. We're rounding it to the tenths. So we're going to keep our answer at 17.4. If a equals negative 2 and b equals negative 3, what is the value of a squared minus b squared? Anytime you have an exponent on your variable and the numbers are negative, always use parentheses around the numbers. So negative 2 to the second power in parentheses minus the negative 3 in parentheses to the second power. Do not change until exponents are done. So again, do not change until exponents are done. So a little abbreviation there, that's change. So in my calculator, you want to use the parenthesis, negative 2, parenthesis 2. Make sure you're using your parenthesis button. So make sure you're putting in the parentheses before you're squaring it. So that's going to give us 4. Same thing here, parenthesis, negative 3, parenthesis 2. That's going to be a positive 9. Bring down the minus sign. If you want to do your change, you can now. So the answer is negative 5. The cubed root of 343, you're just going to simply put this into your calculator and see what it gives you, and the answer is going to be 7. If you're not sure how to do this, so we want to use the generic root button, so we're going to be using the caret button, because that's like the root for anything any root that we want. So you start by putting the root in your calculator first. Whoops. So you put the root in first, second function, then the caret, and then that generic root button, and then 343. So again, if it's not a square root, then you have to use this button. So you would press the root first, 3, then second function, caret, then the 343, and that would give you the answer, 7. So if we're writing a number in scientific notation, there can only be one number in front of the decimal other than a 0. So my decimal is going to have to go right here between the 4 and the 5. So in order to put my decimal point here, I'm going to have to move it 1, 2, 3 places. And since I started with a very small number, we use a negative exponent. I can check my answer or double check it. So when the exponent is negative, we move our decimal to the left as many places as it tells us. So that would be 3, and that would take me back to where I started. This is considered a big number, whereas this one was a small number. This is considered a big number because the numbers in front of the decimal are whole numbers. So when we write it in scientific notation, we're actually going to use a positive exponent, whereas we used a negative exponent here. So the decimal has to be between the 1 and the 2, because we can only have one number in front of the decimal that isn't a 0, times, and since we only moved it one place, it would be 10 to the first. And again, we can double check it. If it's a positive exponent, you move your decimal one place to the right, and that would take us back to where we started. A is 4.9 times 10 to the 8th. B is 2.3 times 10 to the 5th. Then A is about how many times as large as B. So, little typo on the words there. Okay, so if we're looking for how many times larger or is about how many times as large, we're going to divide. So it sounds like a multiplication problem, so to determine the answer, we would have to do the opposite, which is to divide. So I'm going to take 4.9 times 10 to the 8th divided by 2.3 times 10 to the 5th. So a few different ways we could do this. We could just put parentheses around the numerators and denominator, and we could just enter it into our calculator. So you could just do parenthesis 4.9 times 10 to the 8th, close the parenthesis, divided by parenthesis 2.3 times 10 to the 5th parenthesis. By using the parentheses, the calculator would then know that this is all grouped together in the numerator and that this is all grouped together in the denominator before dividing. So that's one way of doing it. Another way of actually working out this problem is using your EE button. So let's say you wanted to do that. You would press 4.9, your second function. The EE button is above the, let me double check. The E button is above the X to the -1 key. And then this means enter exponent. So you would just do 4.9, second function EE, enter the exponent, which is an 8. Notice that I did not press times 10 at all. Then divided by 2.3, second function, the EE button again, which is above the X to the -1, enter the exponent, which is a 5. So the answer is actually 2,130. But let's say that we were doing this without a calculator. Let's say it was on the no calculator section of the test. So what I would do is when I divide, I'm going to look at these two numbers. 4.9 is about 2 times greater. It's about, so this is just an estimate. After all, it did say is about. So 4.9 is about 2 times the size of 2.3. And since we are dividing, we subtract our exponents. We keep the base, subtract our exponents. So you could possibly see 2,000 as the answer instead of 2,130. They are both about how many times larger. So it depends on how or where the question was. Number 12. So write your answer in scientific notation. Again, you could just enter it exactly as is, making sure that you include the parentheses. That is one way of doing it. Another way is to use your EE button. So again, 4, second function, the EE button, and then enter the exponent, which is 5, times 3, second function, the EE button, and then 3. And that would give you your answer, which is 1, 2 with 8 zeros after it. 3, 4, 5, 6, 7, 8. Your calculator may have given you 12 times 10 to the 8th. It may have given you that instead, depending on whether or not that answer fits in your calculator. So 12 times 10 to the 8th is the same thing as a 12 then with 8 zeros. We would just move it 8 places. The answer has to be in scientific notation. That is not scientific notation. Just so you know, that is not scientific notation. Scientific notation only has one number in front of it, which means our decimal has to be here between the 1 and the 2. So if I move it so that it's between the 1 and the 2, it's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So there's my final answer. I already read that, it's kind of hard to see, times 10 to the 9th. So if this were in your no calculator section, you would multiply the 4 and the 3, and that would give you 12. Then you would keep the base, which is a 10, add the exponents, and that would take you to this answer here, and then you would convert it to its standard form, and then into its scientific notation. Suppose it takes 24 hours to fill a swimming pool to an average height of 1.2 meters. If the pool starts out empty, what is the rate per minute? So we're looking for rate per minute. So we're looking for meters per minute. But then it says write the answer using appropriate units. So we have to keep that in mind as we finish up our answer. Okay, so let's look at numbers then. I'm going to take the 1.1 meter, and I'm going to divide it by the 24 hours. But notice over here I want it in meters per minute. So I am going to change my 24 hours to minutes. Since there are 60 minutes in an hour, I'm going to multiply 24 times 60, and that's going to change this to 1,440 minutes. When I divide these two numbers, I end up with 0.00076 meters per minute, and this is where this sentence comes into play. So this is not, that's a 0, I'm struggling with my zeros. Write an answer using appropriate units. This is not appropriate because how much is 0.00076 meters? We could definitely simplify that. So there are 100 centimeters in a meter, and there are 1,000 millimeters in a meter. So I'm going to convert that number by multiplying it by 1,000, and I'm going to change it to millimeters. So if I multiply it by 1,000, I'm going to end up with 0.76 millimeters now instead of meters per minute, and that is a more appropriate unit. Number 14, which of these is an irrational number? Well, this number here, it terminates. It comes to an end. So that is a rational number. So that is definitely not irrational. The answer to the square root of 16 is 4. That terminates. So that is another rational number. 4 1/3 is a fraction. All fractions are rational numbers. This is a non-perfect square. This is a number that goes on forever and ever and ever without repeating and without terminating or ending, we would say. So this is our irrational number. How do I write the repeating decimal as a rational number? So in other words, I have to turn it into a fraction. So since it is repeating, let's say that this is our calculator screen, 0.27272727 until it goes off your screen a couple extra times, then second function f to d, and your answer is going to be 3/11. Number 16, what whole number is closest to the square root of 83? If I put that into my calculator, so second function x squared because the square root's above it, and then my 83, I get 9.1104. It goes on forever because it's irrational, but we're looking for the whole number that's closest to it. So it's either going to be 9 or 10, but it's 9.1. So the 1 tells the 9 to stay the same. So 9 is the closest whole number. Number 17, evaluate 13/2 squares of 6 to the nearest hundredth. So you can just simply use your calculator, but make sure that you group the denominator using parentheses so the calculator knows to divide everything. So we want our calculator to know that we're dividing by the quantity of this grouping here of 2 squares of 6. So we're going to press 2, then our second function, x squared 6, and then you're going to need to close the parenthesis for the square root button. So close the parenthesis, and then we want to close that parenthesis. So there's actually 2 parentheses here. So if you want to just please pick up your calculator and try that so that you understand why we need to have that second parenthesis. This parenthesis closes this parenthesis. This parenthesis closes the square root. And then you just press enter and it gives you the answer. It's about 2.6536. Again, that is irrational. Rounding it to the nearest hundredths, which is the second decimal place. The 3 tells the 5 to stay the same. So 2.65 is our final answer.